Okay. Hello, everyone. Welcome to our presentation for the CIVL 463 and 908 Advanced Soil Research Report. Today, my name is Lan. My first part is the literature review for the summary. We found 10 higher relative papers of the PVD materials, which is try to describe the strength of treated soil related to the topic number 5. So I will be do the research question about how do prefected vertical drains and of this of the strength of soil. So I will be introduce some functions of the PVDs. PVD materials, there will be doing the first function of the prefecting strips. There will be mating in different type of materials and help the foundation engineering to accelerate vertical drainage and improve the strength and reach to the design strength of the strength of the area. And the last point is there will be saving the time for the engineering, foundation engineering, and saving the cost as well. Next part.
Okay. By looking at those reference materials, we get some results such as these are one of the main highlights from some of the projects here, such as the Istanbul project and Singapore project, such as the consolidation is provided by 705 days, and in Singapore project is 140 million meters of PVD has been used. Okay, to get a closer glimpse of the actual effects of the PVD, the Singaporean research team installed some detector to monitor the sediment and instrumented to measure the excess flow pressure. This is the sediment. It shows that this sediment for the PVD will target to reach maximum settlement with PVD installed is much less compared to those who don't. So it shows that PVD actually accelerates drainage. And also to verify this effect, we also measure the pore pressure. So it shows that if PVD is installed, the pressure also decrease after 1.4 years by 50 kilometers per square meter. And also we want to check whether PVD actually increase the shear strength. In this project, they used the field range shear test, and we found out that the shear strength before reclamation is 17.5 in average. And also after improvement, it goes to 47. It's a quite remarkable increase. So in conclusion, it all confirms the assumption of what we have just assumed, and also it shows that the consolidation process has been accelerated, so the time and cost of doing so is decreasing. So we believe that the PVD has achieved its goal.
Next, my name is Aman. I will discuss the part 5, which to verify the results, we did some experimental design. So we compared few different types of sand, which is soft clay, normal sand, and the sea sand. So the different parameters that we considered during the experiments were the what type of PVD it is, the spacing between the pipes, the preload, the strain level, and the value of the dock in percentage. So for soft clay, the type of PVD that is used is basically the flat strip drains or the weak drains. The spacing that we need to keep between the PVD pipe is from 1 to 2 meters. The preload of around 2 to 4 tons per square meters is often used in the soft clay PVDs. And also talking about the strain level, the strain levels is around observed is around 1 to 5% during the consolidation. Talking about the the fine sand, the type of PVD used is the vertical drains, with commonly used. The distance between the spacing of PVD pipes is between 2 to 3 meters, and the load capacity is around 1 to 3 meters, 3 ton per meter square. Talking about the strain level may be observed around 0.1 to 1%. The C sand norm, is similar to the normal sand or the fine sand. The vertical drains are used. The spacing is also considered between 2 to 3 meters. The preload is around 1 to 3 ton per meter square, similar to the normal or the fine sands. And the strain level is also measured is also observed from 0.1 to 1% during the loading. Next part will be explained by Len.
Yeah. From the part 5, the verification experiment design for the PVD, the effective or efficiency of drainage. So I will be divided in 5 points. 5 points of this. First is the efficiency of drainage, which is divided in 3 types of the vertical drains. First is the weak drain strips, and second is the vertical drains. That is the mostly used in our basically in our engineering application. So that can be reached around 30 to 45. Sometimes will be more of our design prediction. The second is about the materials properties factor. The E value and other values will be getting more from the fine and normal sand to the then the C sand. The third predictive result is the efficiencies and spacing of the PVD strip. When we just think about the space enclosed in which is the 1.2 meter, the which will be effective more than 2 to 3 meters for the drainage. The last is the preloading. The preloading is the force actually from which is from the top of the backment to the vertical installation area, from 2 to 4 tons. But the effective will be above the 1 to 3 tons per square meter. And the last predictive result is the compaction level of the strain. Actually, 1% to 5% of the strain will be higher than the 0.1 to 1.1%. I think that will be we can get in a predictive result from our part 5 verification experiment designs. Since last.
The next part is the innovative application, what type of PVDs we can use. So the types of PVDs we can use according to the situation, according to the atmosphere that shoots. The PVDs are the biodegradable PVDs, smart PVDs, the electrokinetic PVDs, and the self-installing PVDs. The type of PVD can be chosen according to the standards or the criteria that match the sites. So this is the reference list we used these are the references we use for the presentations, and that's all from the for the group 18. Thank you.